Hello and welcome to another episode of Study Session 4, AP Calculus BC. In this episode, we will be doing the definition of a derivative, and this is actually my third time recording this because I've been interrupted both times that I've been recording, and it's very annoying, but third time's the charm. So let's start off by getting the conceptual basis of how this is derived. So if we draw something like a quadratic, this is a really badly drawn quadratic. Not to mention it's like super zoomed in. But like if we choose 2 points, let's just say the change in x is like 0.1 or like something reasonably small. If we draw a line between them, we can find like the slope of that line. So change in y over change in x. And we can get like an approximation of what the slope is, at this point or whatnot. But it's not a very good approximation. So we can, so the function, is y equals x squared, but we can redefine this as equals to f of x, okay? So if we make these points infinitely close to each other to the point where they're like a single point, then we can get an infinitely good slope at that point. So that's pretty much what you're doing with the definition of a derivative. So basically what you do is so change in y can be represented if we call change in x h, so x plus h minus x. We can redefine this as x plus h and then minus f of x, okay? And then we want to know as h gets infinitely close to 0, so we can actually take the limit that should go there as h approaches 0. And from now on in the video, this equals big L. So big L equals that because I'm lazy and I've already wrote this like 2,000 times today. And I don't feel like writing it anymore, but it's going to be great. So another quick thing is like let's say you had a function and it looked a little bit like this. This at that given point is not, I'm going to butcher the pronunciation of this, differentiable. Because you would have one slope that goes up like that and one slope that goes down, and you can't have two slopes. You cannot have two slopes at that line. You can't. That's a no bueno. So that's a big no. Okay. So let's get into some practice problems. So problem number 1. So f of x equals 5x. Okay, and it wants to know what the derivative is at x equals 3. Okay, so we can redefine this as the limit, so big L, as x approaches h, of f of x plus h minus f of x, all of that over h, okay, and we can redefine this as 5 equals L times 5x plus h minus 5x, all of that over h. Okay, and then we turn that into 5x plus 5h minus 5x, all that over h. Those cancel out, and we get 5h over h cancels out equals 5. If we think about it, the slope should be 5 because it's a linear equation, and that's a coefficient. And the coefficient is always the slope. Y equals mx plus b times the slope. So that makes perfect. No, I don't want to do that. That makes perfect sense if you think about it. Okay, so the next one is f of x equals 5x squared at x equals -1. Okay, so I already know like derivative rules and stuff, so I'm going to predict that the derivative of this should be 10x and as such -10 as your actual calculated derivative. So let's do it. So the limit of, I'm not going to write f of x plus h because that's a lot of writing and I don't have a lot of room. So 5x plus h squared minus 5x squared over h. Okay, we multiply these out. We get 5x squared plus 10xh plus 5h squared minus 5x squared, all of that over h, plus 5 or minus 5x squared plus 5x squared. Those cancel out. We get 10xh plus 5h squared, all of that over h. Factor out an h. Get h times 10x plus 5h, all of that over h. H's cancel out. And then, so we know that h is approaching 0, and 0 times anything is 0, so that simply cancels out. And we get 10x. Plug in a -1 for that, you get -10. So it's yeah, it's pretty simple, pretty snazzy. So going on to the next one. Gonna quickly crunch these out. Third time recording this. Don't have a whole lot of time left. But, okay. So, the next problem, I'm going to go ahead to a more advanced problem. F of x equals 2 square root of x at x equals 9. Okay, I already know that this is going to get ugly because I'm using a square root. So anytime I go to see x, I'm just going to go ahead and plug in 9 because it'll make the whole process a lot simpler, you'll see. So the limit as 2 square root of x plus h minus 2 square root of x, all of that over h. Okay, so we can redefine this. You know what, first off, let's, so we know we have, the difference of these two. So let's multiply by its conjugate. So let's multiply by, I'm going to go ahead and factor out this 2 just to make my life easier. So I factored out that 2. That's what I did there. So we can multiply this by the square root of x plus h plus the square root of x. And then this will turn this into x plus h minus x. Those will cancel out. All that over h times square root of x plus h plus the square root of x. Okay, so we end up with h over, I'm just going to draw a line here so that doesn't conflict, h times the square root of x plus h plus the square root of x. Okay, h's cancel out, you get 1 over square root of x plus h plus the square root of x. And we know that h will be approaching 0, so we can really write this as the square root of our 1 over 2 times the square root of x, or whatnot. 9 is your x, so that's 3. So, what do you call it? Sorry about that. Sorry, 1 second. I have to go check something real quick. Okay, so I'm back. Sorry about that. I thought I was being really dumb because I was looking at my camera like, man, why am I getting the wrong answer? Because if I substitute in 9, I get 2 times 3, which is 1 over 6. 1 over 6. I was looking at my answer and it was telling me it was 1 over 3, so 1/3. But I factored out this 2 earlier on to make my life easier, and I forgot about it. So 2 times 1 over 6 equals 1/3. So that's how you solve that one. I was really confused as to what I did wrong there. But yeah. So if you're going to factor something out, make sure you keep track of it, because I learned that the hard way. Okay. So our last one will be f of x equals 1 over x. Okay. So we can rewrite this as 1 over x plus h minus 1 over x, all of that over h, multiply by to get common denominators. So we get x minus x plus h, all that over x plus h. Okay, so we get negative x and negative h. Those cancel out. So we get this will carry down to the denominator. So we get negative h over h x plus h. Okay, these cancel out, so we get negative 1. And if remember, h is going to approach 0. So h is approaching 0, so that's x squared. So negative 1 over x squared. And that is correct. Okay, so hopefully this helped with the definition of a derivative and applications, and just like a good review resource. Hopefully you guys will join us in the next episode. And once again, sorry for the interruption halfway through there. I would have re-recorded it naturally, but I've already recorded this 3 times, so hopefully that helped, and that's the wrap of this video.